So for Pythagoras' theorem, as we just discussed, to save you from rearranging the formula all the time, it's easiest if you can memorize the two bottom ones. If you're trying to find the hypotenuse or the longer side, you're using h equals big square root of a squared plus b squared. Or c if you want to use the c in there. If you are trying to find the shorter side, you use a equals square root of h squared minus b squared. You're taking away the shorter side. Okay? Hypotenuse minus the shorter side. So hopefully you remember those formulas from previous lessons, previous years. Let's jump straight into examples. So example number 1, you can see that we're trying to find the hypotenuse there, h for hypotenuse. So the hypotenuse formula is h equals square root of a squared plus b squared. And then all you have to do is substitute into that. It doesn't matter which one is a and which one is b. So I'm going to go 6 squared plus 8 squared. Okay? You can type that whole entire thing into your calculator. Anyone done it? Or anyone know the answer? Yes, it's 10. Okay, now this is a measurement section of work, so please remember to include your units. That is in centimetres. Okay? Question 2, x is also the hypotenuse. It's straight across from the right angle, so it's the hypotenuse as well. So again, we're using the same formula. H equals big square root sign a squared plus b squared. Okay? A and b, doesn't matter which is which. I'm going to say that a is 9, so 9 squared, and b is the 12. That one also works out really nicely in your calculator. It's 15. And the units are metres. You can ask me to slow down if you'd like me to slow down, but the faster I go, the more time you get to practice before the end of class. Is everyone okay so far? Yeah. Cool. All right, question 3. I am trying to find A over here, which is right next to my right angle, so that's one of the shorter sides. The shorter side formula is big square root, hypotenuse minus the other side, squared. Okay? Now this one, it is important which one is which. The hypotenuse has to be that 2.6, and the b is going to have to be that 1. So subbing those in, you will get 2.6 squared minus 1 squared. And that comes out as 2.4 centimetres. One more time. A is again on the shorter side there, so I need A equals square root of h squared minus b squared. H, girls, h must be the hypotenuse, which is the 17. B has to be the 15. Okay, so when you're finding the shorter side, it's very important that you put them in correctly. If you don't, you're soon going to know that you put them in incorrectly because you're going to be trying to subtract you're going to get a negative number under that square root sign, which you won't be able to get an answer for. Okay, so you're going to know if you put them in the wrong way. So that's 8 kilometres. Okay, hopefully you guys are pretty comfortable with that. Question 5 is just to show you a harder version of Pythagoras' theorem. This is Pythagoras in 3D, basically. It says the length of the diagonal of the base of the rectangular prism is 7.4. That's where that's pointing, that arrow is pointing to down there. And the rectangular prism's height is 4.2. The distance from one corner of the rectangular prism to the opposite corner, give your answers to 3 significant figures. You've already got the right angle triangle, it's just that it's kind of sloping through that rectangular prism. 7.4 is one of the shorter arms, and 4.2 is the other one, and we're trying to find that hypotenuse again, which is over here. Okay, so it's just h equals 7.4 Oh, I should write the formula down first. Let me write the formula for you. A squared plus B squared is our formula. A, I'm going to call 7.4, and B is 4.2. Okay, now there is one extra catch to this question. It says find the answer to 3 significant figures. Do you remember how to round to 3 significant figures? All right, so when you type it in, you will get this 0, 8, 8. Is there a 1 after that? Maybe not. Anyway, that's too many significant. You get that, okay? 3 significant figures. You always start counting significant figures from the very left-hand side, okay? The very first number here, the 8, that's my very first significant figure. All numbers other than zeros are always significant, okay? It's the zeros where the trick is. Zeros are significant when they're between other numbers, and they're significant at the end of a decimal number. So something like this, 2.50, that 0 on the end would be significant. But they are not significant if they're at the end of a normal number like that. So 250, that 0 on the end would not be significant. They are also not significant if they're in front of a decimal number like that, 0.01. That would only have 1 significant figure. Okay, so that's just a quick recap of significant figures. If I want to round this number to significant figures though, starting from that left-hand side, I want the 8, that's 1. The 5 is 2. The 0 is between some other numbers. It's going to be my third one. Okay? Anything after that, I'm crossing the ones I want. That's probably a bit bad. Maybe I should be ticking them. Ticking the ones I want. Okay, let's try that again. Tick. I want that, I want that, I want that. Okay? Everything after that 0 has to be rounded off. So I'm basically rounding to 2 decimal places here. The 8 is obviously above 5, so I'm going to have to round up by 1. And it will be 8.51 meters. And that's 3 significant figures. Okay? Yeah.
It's just like if it ended at 0, it would just be 8.50.
Yeah, so if it actually ended at 8.50, that still has 3 significant figures because zeros on the ends of decimal numbers are still significant. Yeah, good. All right, so that is the end of the Pythagoras theorem question. For the 2 of you that have just joined us again today, this booklet is all in one. Okay, so your questions, I put them in here to try and save us some time this year, just for the first topic. I'm not going to do this for all topics. So they're going to be your Pythagoras theorem questions there. But we're also going to do a second one today for the first time. We're going to do 2. Where is my second one? Here it is. So skip over your questions. We'll come back to those. Let's go to 1D. So area of triangles, quadrilaterals, circles, and sectors. Again, you can see this is a revision topic. You've done this many times before. The formulas are listed there for you. Some of you may have learnt different formulas. So, for example, for a rectangle, me personally, I prefer A equals BH. Does anyone else prefer A equals BH? Yeah. So use A equals BH. This is just the table that came out of the book. Okay. Is there any other ones there that are different to what you're used to? For the trapezium, I just memorize 1. Don't memorize 2. I use that first one that I've highlighted. Does anyone like the second one? Oh, yeah, we have one taker for the second one. Okay. That's fine. Any other formulas there that look different to what you're used to seeing? So the circle is pi r squared. A sector is just part of a circle, isn't it? We have one little wedge cut out of it, a piece of pizza. Does anyone remember what this symbol here is called?
Theta.
Theta, excellent. It's just a Greek letter. There's a lot of chatting around the room. It just represents the angle that you're cutting out. Okay, so if it's a 120 degree wedge of pizza, it'll be 120 over 360. It's saying what fraction of a circle do you have? A rhombus or a kite, both of those 2 shapes have this same formula, half xy. The x and the y are the lengths of the diagonals. All right, any questions about any of those other formulas? No? Good, all right. Down the bottom, I have a conversion diagram for you. So you know how to convert between millimeters, centimeters, meters, and kilometers. There's 10 millimeters in a centimeter, 100 centimeters in a meter. So you're used to that kind of conversion. As soon as it is area, you remember that areas are always centimeters squared or meters squared. So you have the same 10, 100,000, but it's now 10 squared when it's area, or 100 squared when it's area, to get between converting units of area. You've probably seen that diagram before as well, right? Yes? Hopefully. The bit that might be new, do you know what a hectare is? Okay, a hectare. Do you know what we measure in hectares? Sorry, yeah, I think I heard, sorry. Land, yes, perfect. If you buy a large block of land, it's normally measured in hectares or acres, but hectares is one of the options as well. So a hectare is 100 metres by 100 metre block of land. In other words, 100 times 100 is 10,000 metres squared. So you probably need to add that to your sheet. That will be needed in some of your questions. 1 hectare, HA for hectare, is equal to 10,000 metres squared. All right, let's then do our examples. Or if I leave my diagram there, we can do the converting at the same time. Convert these areas to the units shown in the bracket. So they're not just centimetres and millimetres, these are centimetres squared and millimetres squared. So that's why we need this squared diagram, okay? So centimetres squared are here. To get to millimetres squared, I need to times by 10 squared. So you go 4.5 was my starting number, and I need to times by 10 squared. Okay, that equals 450 millimetres squared. Always write your units on your answers. The next one, I have centimetres squared, and I want to get to kilometres squared. So it's 2 jumps, but follow the arrow, divide by 100 squared, divide by 1,000 squared. So 300,000 divide by 100 squared, divide by 1,000 squared. Very small number, 0.000, we've got enough zeros, 1, 2, 3, 4, yep. 3 kilometres squared. Could you imagine centimetres squared are very small, whereas kilometres squared takes an awful lot of centimetres squared to fill a kilometre squared. Okay? Any questions so far? Question 2. Area. Now you would have heard in Year 8 and Year 9, show your working out. Okay, so first of all, identify the shape. The first one here is a trapezium. Write down your formula for a trapezium. Now the one that most of us I think use is h over 2 bracket a plus b. Then substitute into your formula. The h is the perpendicular height between those two parallel sides. The a and the b are the two parallel ones. Now, I've said A is the top and B is the bottom, but it actually doesn't matter which one is which, okay? Sub that into your formula. 15 for H over 2. A is 10 plus B is 25. And then in the calculator. Okay, centimetres squared, because we're doing area. Circle. Maybe I should start memorising people's names that I don't know. Who does know the area of a circle? May I know your name? Oh, yeah, sorry. Pi r squared. A equals pi r squared. Okay, R obviously stands for radius. So is that a radius? No. What is the radius? No. Did you say quarter? You'd have to halve it. So the diameter, what I've got there is the diameter, which is the whole way across. The radius is only going to be half of that distance. So I halve 25, which would be 12.5. Okay? So make sure you've got the right measurement to substitute in. Pi times radius is 12.5 squared. 490.87. I'm giving you the final answers here to save us calculating time, but it actually is an important step. The number of people who can actually write down the substitution line but make a mistake typing it in, just be careful. Make sure you put everything in properly, okay? Question C. In C, area of a triangle. Formula. Who wants to tell me? Someone different.
Half BH.
You told me the last one. But thank you. Oh, okay. Half BH. The base and the height, doesn't matter what type of triangle it is. Okay, you can have obtuse angled ones like this, or a normal kind of one, a right angled one. The base and the height are always the two sides connected by the right angle. Okay, so here's the right angle, which means my base is the 7.4 and the height the 2.3. So half times 7.4 times 2.3, which is 8.51. Now I can't include units for that because I wasn't given any, so we just have to leave it there. And D, this is known as a sector, just a very, very large one. Anyone want to have a go, or are you peeking at the sector formula? It starts with an A. Now you actually have to memorize these, so you have to start practicing. A equals, this is the one with the theta. Theta over 360 times by pi r squared. Remember back in year 8 when you had your formula test and you had to memorize all these formulas? Yep, same formulas. Okay, so the radius is the 2, the theta is just the angle, it's 310. So, sub it in. Plug it in. Now I have rounded that to 2 decimal places because I had to round it somewhere. It didn't specify, I've just done 2dp. Anything involving pi is always going to need to be rounded. Okay, E. I think some of you are trying to get ahead, which is great, but please keep the chatter down. It's not time for talking, okay? Part E, I am trying to find the area of this shaded, this bit in here, this shaded section that I'm shading, okay? So you've got 2 shapes there, really. You could try to do a square plus this weird shape. That's not really going to work though, is it? Because I don't really have a formula for that weird shape. But I do have a formula for that one. Okay, that's a sector over there. So what's better to do is the whole outside shape and subtract off this sector here. Now, how many people in here like to do an area 1, then an area 2, and then a total? Does anyone do that method? Maya does? Yep, a couple people. Are a lot of you used to putting both the formulas together? Have the rest of you tried doing that? That's my preferred method at this level, trying to put it together into one line just because it should save you some time, okay? But I am happy for you to still do it separately if that's where you feel more comfortable. So, to do them together, area 1, the first area, the outside shape, would be a rectangle, which would be A equals BH, right? I need to subtract from my rectangle the sector that is out there, which is theta over 360 times pi r squared. Still lots of mumbling. Now, the base and the height of my rectangle. Now, I know that the height is 4. I also know that that one there would be 4 and that one there would be 4 because of the markings. So that would mean that the base of my rectangle would be 8. Okay, so 8 for that total base and the height of 4. The sector, because it's a rectangle, that has to be a right angle there, even though it hasn't specified it. It would need to be 90 on the top over 360 times by pi. R is, what's R? 4. Remember, that's the center of your circle there, and that's a quarter of your circle. So the radius is 4 squared. Okay, and that comes out to be 19.43 meters squared. Now, there is a question in your book that you're going to do where it wants you to give this kind of question with an exact answer. How would you, do you think, give an exact answer for something that involves pi? Okay, obviously it means that my answer is going to still have pi in it. Okay, so what we do instead, if I, just as a side note for when you have to do this, you start from that line there, okay, back to this line. If I wanted to do it exact, so let's say for exact answer, h times 4, guys, if you need to be talking about it, maybe you should be listening instead, okay? No talking, please. h times 4 is 32, okay? Minus, so I'm just working from this line here again, h times 4 is 32. I want to work out all the parts in here, just leaving the pi out. Okay, because the pi is where the decimal part comes in, okay? So if you type into your calculator, and everyone do this please, 90 over 360, leave the pi out, times 4 squared. What do you get? 4. So all those numbers in there just come out to a 4, and then I put the pi at the end of it, just like that. Okay, so that is the exact way to write the answer, 32 minus 4 pi. All right, so remember that. You're going to need to do that. Question 3. Find the value of the unknown pronumeral to 2 decimal places. So this is actually going in reverse. I'm giving you the area, and you have to find the height of that rectangle. So just like before, if you know it's a rectangle, start by writing the formula down. A equals BH. But this time it's just that we're substituting the area in. Okay, so my area is 21, so under the A is 21. My base is 4.2, and my height is y. Okay, so now it's a little equation to solve to get the y by itself. Now, to get the y by itself, I'm going to divide by 4.2. Now, I'm doing this in red. Do you guys still write all your instructions when you're solving equations, or do you do it without it? Without. Excellent. If you're able to solve equations without doing the little minus this number, minus that number, it is going to be beneficial in the long run because you'll be faster. Okay, you can do more things if you can go faster. But if you still need to do them for now, then please keep doing them, okay? So, something to work towards. That means those 4.2s will cancel off. Y is by itself. And 21 divided by 4.2 is 5. And I do have units for this one. It's in meters. No, this is meters. Because I'm actually going from the area and I'm going back to a side length. Good question. So it is just meters. All right. B. It is a trapezium. So the trapezium formula is A equals H over 2 bracket A plus B. Okay, sub in all the things that we know. Down here it tells me the area is 51.3. Equals the height. Which one's the height? The 3. So 3 on the top. Over 2 bracket. A and B are these two parallel ones. I'm going to put my y first because we normally like having our y's at the beginning of things. Y plus 7. This one's a little bit more complicated to rearrange. What do you think the first thing I should move is? Hands up. Who knows? What should I move first? Away from that y. Yes, Haley? No, never mind. Who knows? What? I've got a 3, a 2, and a 7. I've got 3 different numbers there around that y. Which one goes first? Haley again? No. 3? Any advances on the 7 and the 3? It's the 2. Yes. Okay, I can't do that 7 because it's in brackets. It's been affected by this. Okay? That 3 is being affected by the 2. Okay? It's been divided by 2. So the one that I can move away is that 2. Get rid of it. So, I'm going to times by 2 to get rid of that. So 51.3 times 2 is 108. No, yeah, 108 point. No, it can't be. Is that right? No. I've written that down. That's not right. Yes. I'm looking at my notes. I must have written the wrong number in there. Look at that. All right, 102.6 equals 3 bracket y plus 7. Okay, so what should I move next? You can expand the brackets if you really want to, but that's an extra step. I don't have to. What should I do? Divide the 3. Okay, so we're going to divide the 3. Get rid of that. So 102.6 divided by 3 is 34.2. So I'm going to move it to the other side. Y plus 7 is equal to 34.2. Prefer the y's on the left, so at some stage you need to switch sides. Okay, last step is to subtract that 7. Write the instructions on there for you, those of you who like it. So minusing that 7 off is 27.2 meters is the length of the base of that trapezium. Okay, and we've hit our next exercise, so that's 1D in there. All right, so that's it what you're doing today. Pythagoras' theorem and some area.